Hello Year 10. I hope you've been enjoying this week's challenge about problematic postcodes. Before we look at the challenge, here's a map of London postcodes, which I thought would be interesting. In particular, how are they ordered? How are they arranged? You can sort of see there's E1 there and NW1 there and W1 there. So it's sort of the ones are all in the middle, but E4, say, there is nowhere near 3 and 5. It's next to 17 and 18. So there's a question for you. What is the structure? What is the order of London postcodes? Why are they not in any sort of numerical order? The actual challenge was about American postcodes, what are called zip codes. And the idea is that if you write a zip code like 06061, and then for some reason the envelope gets turned upside down, it goes into the machinery the wrong way round, it might look like the zip code 19090, and that might be confusing. So the question is, how many confusable zip codes are there? So what we're thinking about is when we take a sequence of 5 digits and rotate it 380 degrees, sort of turn it upside down like that, when does it look the same? And obviously it depends on handwriting. You could argue that the one there and the one there don't look the same. Obviously if the one was more of just a straight vertical line, then when I turn it upside down, it would look exactly the same. So we have to decide carefully which digits we're thinking about. I certainly think 0 and 8 definitely look the same, 0 and 8 when they're upside down. I think 1 probably looks the same, and 6 and 9 look the same but not at each other. So 6 looks like 9 and 9 looks like 6. 2 and 5, well, it depends how you draw them. The more you draw a 2 like a Z, the more it looks like itself upside down, and the more you draw a 5 like an S, it looks like itself upside down. So it depends on your handwriting, really. So a confusable zip code is one made with only these digits. So the zip code 18968, when I rotate it 180 degrees, when I turn it upside down, looks like 89681. And therefore that could be confused by the machinery. Possibly that one does, 92165. With a little bit of kind of generosity, that will look like 59126 when we turn it upside down. Again, the more I draw my 2s like Zs, the more I draw my 5s like Ss, the more likely it is for that mistake to be made. Let's just concentrate on 01869 for the time being, because I think we all agree they're definitely confusable when they're rotated 380 degrees. So how many zip codes can I make using only those 5 digits? Well, to make a zip code, there are 5 gaps to fill. I've got to put a digit there, a digit there, a digit there, a digit there, and a digit there. I've got 5 choices, and then 5 choices, and then 5 choices, and then 5 choices, and then 5 choices. And a way of thinking about this is like a tree diagram. So there'll be 5 branches for the first gap, and then for each of those branches, there'll be 5 branches coming off it. So that's 25 branches in total. And then for each of those, there's 5 coming off. So that's 5 times 25 is 125. And then for each of those, there's 5. That's 625. And then for each of those, there's 5. And so in total, that will be 5 to the power 5, or 3,125 possibilities overall. 5 here, 5 here, 5 here, 5 here, 5 here. And if you think of the tree diagram, it's going to be 5 times 5 times 5 times 5 times 5, because for any 5, there's another 5 coming off each one of the 5. I didn't draw it. It would be a very bushy tree. But if you think about it, in that way, you should see why they're being multiplied together. So that means out of the 10 to the 5 possibilities, there are 5 to 5 I can't have. So 5 to 5 use only those digits there, the confusable digits, out of the 10 to the 5 altogether. So that means that about 97%, all the other ones, are okay, are not confusable. So here's an example of one. So it's got 1, 8, 9 and 18, which are confusable, but the 4 prevents it being confusable. It's at least one non-confusable digit. How did I get 97%? Well, I worked out what that was as a percentage, which is quite easy actually, because it's 5 out of 10, which is a half, to the power 5, so it's 1 over 32, so it's about 3%, because 1 over 32 is nearly 3 over 100. I mean, obviously it's 3 over 96, which is nearly 3 over 100. So the ones I can't have are about 1 out of 32, so the ones I can have are about 31 out of 32, which is about 97%. So what happens if we include the 2 and the 5? The 2 and 5 I think are a bit more ambiguous whether they're confusable or not, but if you include the 2 and the 5, you're now going to have 7 choices at each when you fill in each of the gaps in the zip code. And so how many would be confusable, and therefore how many couldn't be used, and so how many could be used. What about with UK postcodes? Because UK postcodes, as you know, like your own postcode in London, uses letters. So obviously some letters, like S and Z, look like other letters, but also some letters might be confused with numbers, like E and 3. So think about what the effect of that's going to be. It's more complicated in the UK because we have, in the UK, sometimes we have postcodes with 6 letters or digits, and sometimes we have 7 letters or digits, depending on the postcodes. So what percentage of UK postcodes can be used? The other complication, slightly, just for your interest, is of course that we don't use every single letter, every single possible combination. So these are the UK postcodes. This is how they start. The London ones are special. We looked at those a moment ago. But if you sort of take, so say BN down there, that's for Brighton. And so areas near Brighton all begin with BN. And as far as I know, there isn't a BM or a BO. So it isn't actually the case that we use every possible postcode. We've got some left in reserve. But interesting fact for you, little trivia for a lockdown Zoom quiz maybe. Where has postcode BIQQ1ZZ? Answer, well, the answer isn't King's Math School, but where does have that postcode, and would you like to go there? Bye for now.